Now let's get into the second kind of load balancers we'll see is the application load balancer. So it's a layer 7 only load balancer, so that means HTTP, and it allows you to route to multiple HTTP applications across machines. And these machines are going to be grouped in something called a target group, and it will make a lot of sense once we get into the hands-on. It allows you to load balance to multiple applications on the same EC2 instance, so using containers and using ECS as we'll see, and it has support for HTTP2 and WebSockets. It supports redirect as well, so if you wanted to redirect traffic from HTTP to HTTPS automatically, it could be done at the load balancer level. It also supports route routing, so there's routing based on different target groups. For example, you can route based on the target path of your URL. For example, example.com/users and example.com/posts. /users and /post are different routes in your URL, different path, and so you can redirect these two things into different target groups. We'll see what that means in a second. You can also do routing based on the host name in the URL. So if your load balancer is accessed using one.example.com or other.example.com, it could be routed to different target groups. And you could also be routing based on the query strings and headers. So for example, example.com/users and ID equals 123 and order equals false could be routed to a different target group. So ALB, and this is the short for application load balancers, they're great when you have microservices and container-based application. So as soon as we'll go into learning what Docker is and Amazon ECS, ALB are going to be the go-to load balancers, because they have a port mapping features, which allows you to redirect to a dynamic port on the ECS instance, and again, more on that directly into the ECS section. And in comparison, if we wanted to have multiple applications, okay, behind the classic load balancer, we would have to have multiple classic load balancer. We need to actually have one per application. Whereas with load balancers, we're able to have one application load balancer in front of many applications. So maybe a graph will help. So we have our external application load balancer, it's public facing. And behind it, we have our first target group made of EC2 instances. And this one is going to be routing for the route/user. And we have a second target group made of EC2 instances again. And this one is going to be our search application, and there's going to be a health check as well with it. And it's going to be routed through rules for the /search route. So as we can see here, we have two independent microservices that do different things. The first one is the user application, the second one is the search application, but they're behind the same application load balancer, which knows how to intelligently route to these target groups based on the route that is being used in the URL. So the target groups, what are they? The first one is that they can be EC2 instances, and they can be managed, as we'll see very, very soon. They can be managed by an auto-scaling group. It could be ECS tasks, and we'll see this in the ECS section. It could be Lambda functions, and this is something that's not very known. So application load balancers can be in front of Lambda functions, and we'll see what Lambda functions are in the future section, but they're the base of everything called serverless in AWS. And finally, it can be front to IP addresses, and they must be private IP addresses. So ALB can route to multiple target groups, and the health checks are going to be done at the target group level. So let's take another example, and we have an ALB, and we have two target groups. The first one is based on AWS with EC2 instances, and the second one is going to have private servers on premises, so in our own data center. And so for the target group to be able to exist, we need to specify the private IP of our servers into the target group for them to be registered. And now say we have an application that is serving its request through the ALB, and what we want is to send to the first target group all the mobile-based traffic, and to the second target group all the desktop-based traffic. For this, we can use, for example, query string or parameters routing. So if in the URL that the clients are trying to use, there is a question mark platform equals mobile, we can write a rule in the ALB redirection rules, the routing rules, to redirect to the first target group. And if you have question mark platform equals desktop, so this is a query string or a parameter, then we could say to redirect to the target group number 2. I don't know why you would do this, but this is just an example I'm providing you, okay? So good to know before we go into the hands-on. The first one is that you also get a fixed hostname with your application load balancer, just like the classic one. the application servers don't see the IP of the client directly. The true IP of the client is going to be inserted instead in a header called x forwarded for. And so you can also get the port using x forwarded port and the protocol using x forwarded proto. And so what that means is that our client's IP, which is 1, 2, 3, 4, 5, 6, 7, 8, is directly talking to our load balancer, which performs something called a connection termination. And when your load balancer talks to your EC2 instance, it's going to use the load balancer IP, which is a private IP, into your EC2 instance. And so for the EC2 instance to know the client IP, it will have to look at these extra headers in your HTTP request, which are called x forwarded for, port, and proto. Alright, that's it. Now let's go into the hands-on and create our first application load balancer.